Bismillahirrahmanirrahim. Exercise 3.4, question number 4, part 3, integral square root of 4 minus 5x square into dx. The formula for integration by parts considering f as first and g as second function is first function constant, integral of second minus integral derivative of first into the same integral. This integral again comes here, bracket close, and we have dx. The previous knowledge which we need here is derivative of square root of 4 minus 5x square. It is equal to 1 by 2 times square root of 4 minus 5x square into d by dx of 4 minus 5x square. The derivative of 4 is 0 and of minus 5x square is minus 5 into 2x, that becomes minus 10x. We have applied chain rule here. And then this 2 and minus 10 got cancelled. As a result, the derivative of this expression is minus 5x divided by square root of 4 minus 5x square. Also, we will need integral of 1 dx equals to x plus c, and integral of 1 by square root of a square minus theta square into d theta equals to sine inverse theta by a plus c. The important point to be noted here is that if we have theta here, then we need d theta here. Okay, and now we are going to use these results when we will need d by dx of 4 minus 5x square here. Then we will write this result directly. Okay, now let's start the solution. I'm going to introduce a 1 here. Integral I is equal to integral square root of 4 minus 5x square into 1 into dx. Now we are going to perform integration by parts considering this as first function and this one as second function. So let's perform integration by parts. We are going to do integration by parts. I have written integrate by parts, and I get integral I is equal to first function constant, integral of second minus integral bracket starts derivative of the first function 4 minus 5x square into the same integral 1 dx bracket close and dx. Now write this result and this result and this result directly from this sidebar, and you will get square root of 4 minus 5x square into x minus integral minus 5x divided by square root of 4 minus 5x square into x and a dx. This is it. Now, and this is all equal to I. Now I'm just going to arrange the things a little bit. I write it like this: x into 4 minus 5x square, then minus outside, keep this negative sign inside. Okay, minus 5x square divided by square root of 4 minus 5x square into dx. And now what I'm going to do, I'm going to add a 4 here and subtract a 4 from it. Now that is, I will get integral I is equal to x into square root of 4 minus 5x square minus integral 4 minus 5x square minus 4 divided by square root of 4 minus 5x square into dx. That is, add and subtract a 4 in this numerator. Now we are going to split this fraction into two fractions, x into square root of 4 minus 5x square minus integral. One fraction becomes 4 minus 5x square divided by square root of 4 minus 5x square. The other fraction becomes minus 4 divided by square root of 4 minus 5x square. My x and square have been merged into one another. I'm going to write it once again: 4 minus 5x square. And I put both these inside this bracket. Now I'm going to use a simple algebraic result. This result over here. As a result, I will get that integral I is equal to x into square root of 4 minus 5 x square minus integral sign square root of 4 minus 5x square minus 4 divided by square root of 4 minus 5x square, both the fractions inside the bracket and a dx outside. Now, in place of this, we have got this using this result that whenever we divide x by square root of x, the answer is simply square root of x. So when we divide 4 minus 5x square divided by square root of 4 minus 5x square, then answer will be square root of 4 minus 5x square. Now, we are going to open up this bracket. As a result, we will get two integrals. One integral will be minus integral sign this expression and dx, and the other integral will be minus and minus plus integral sign this expression and dx. Let's write both of these, and we get integral I is equal to x into square root of 4 minus 5x square minus integral square root of 4 minus 5x square minus and minus and into dx. Of course, I can add a dx here plus I think I better write it properly. These are not written properly. Here it is 4 minus 5x square dx plus minus and minus plus integral 4 divided by square root of 4 minus 5x square and dx. Now have a look at this one. This is this result, this integral. So its name is I. So I am going to use I here. I will get I is equal to x into square root of 4 minus 5x square minus I. And here I am bringing this 4 outside. 1 by square root of, and just see what I am writing here. I am writing 2 square in place of 4 and minus I am writing square root of 5x whole square in place of 5x square. Why I have made these adjustments? We will discuss it just now. Have a look at this. First of all, bring this I over this side. So it will become I plus I. Write the next, this expression, x into square root of 4 minus 5x square. And now let's talk about this adjustment. Why I have made this adjustment? I'm going to use this formula. You can see we have an a square here and a theta square here. I had 4, so I wrote it as 2 square, 2 square. So by this, I get to know that the value of a is 2. And I need something square, theta square here. I had 5x square. So I wrote it as square root of 5 into x whole square. Now I know what is in place of theta. In place of theta, I have square root of 5x. So I have theta is equal to square root of 5x here. Now I need d theta here. What will be d theta? D theta will be equal to square root of 5 into dx. I have only dx here. So what I am going to do, I am going to divide by square root of 5 and I am going to multiply by square root of 5 and I have our dx here, and in the denominator I have 2 square minus square root of 5x whole square. We have written this 4 as 2 square and this 5x square as square root of 5x whole square, so that we can see what is a and what is theta. And we may also see that whether we have d theta here or not. Now we have d theta here. D theta is equal to square root of 5 into dx. Now we can perform integration. And what will be the answer? This will be the answer of the integration. Sine inverse theta by a. In place of theta, I will write square root of 5 into x. In place of a, I will write 2. So let's perform the integration. From here I get 2i. Then I have x into square root of 4 minus 5x square. Then I have 4 by square root of 5. And now I am using this bracket. And I am writing the result of the integral. And what is the result? It is sine inverse. In place of theta, I have square root of 5x. In place of a, I have 2 bracket close plus a constant of integration, and then I am going to close my bracket. And now what? Let's divide both the sides by 2. As a result, I get I is equal to x by 2 square root of 4 minus 5x square plus 4 by under root 5, and comes this by 2. I'm dividing both sides by 2. So I will have a 2 here. Result, this 2 will be cancelled by this 4, and I will have this bracket. Here is my bracket, and I am going to write sine inverse square root of 5x by 2. Be careful that your square root sign must be over 5 only, not over x. And C1, that is it, only C1, not by 2. And then close the bracket. I'm going to close the bracket now. Now open up the bracket. Let's see what do you get. Integral I is equal to x by 2 square root of 4 minus x square plus 2 by square root of 5 sine inverse square root of 5 x by 2 plus 2c1 by square root of 5. Now put 2c1 by square root of 5 equal to c, and what you will get? You will get I is equal to x by 2 square root of 4 minus 5x square plus 2 by square root of 5 sine inverse bracket starts square root of 5x by 2 plus c, and that is the answer. Let's see, students, if someone does not use this bracket here and directly go for a constant C1, then what he or she will get. If a student does not use this bracket and directly go for this result, I'm going to write this result for you. That is, if a student writes it like this, 4 by square root of 5 sine inverse square root of 5x by 2 plus C1. That is, he or she does not use bracket, use C1 just outside. Then what will happen? When he or she perform the next step, then both sides will be divided by 2. This will be the next step. And then this 2 will be cancelled. The answer will contain 2 by square root of 5 sine inverse square root of 5x by 2 plus C1 by 2 instead of 2C1 by square root of 5. That student will have this thing, and then he or she will put C1 by 2 equals to C, and his answer will be the same. You can see there will be no difference in the final answer. So it's okay if someone does not use this C1 with this instead of it. If a student uses this C1 just outside, that's just like this, then the value of C1 and 2C1 by square root of 5, these will be different, but in the long run you can say he or she will have the same answer. So if someone uses it like that, it's okay, no issue with that, but this is the technically correct solution.